6, show by suitable net ionic equations that each of the following species can act as a Bronsted-Lowry base. And then we have letter F. So we just have to show now that H2PO4- is acting as a Bronsted-Lowry base. I do remember that a couple of questions ago, we did the same one, but it was acting as a Bronsted-Lowry acid. So if this can act as a base and an acid, it's called an amphoteric, ion. It can act as an acid because I see that I have H's in the front. Anytime that you see you have an H in the front, it can be classified as an acid. And anytime that you see a negative charge for an ion, it could act as a base. So this one's got both of them. But anyway, all we got to do is work with the base for this question. Bronsted and Lowry were two scientists that worked independently on acids and bases, but they came to the same conclusion. They both found out that for bases will always accept hydronium ions. Hydronium is represented by an H+. It could also be called a proton, or it could also be shown as H3O+. But for now, we're just going to say that it's H+. Where do they accept these H's from? Always the acid. But in this case, we're just going to show the net ionic equation, which just means that I just need to accept one H+. Now, how do I write that? Well, the base that they told us has to come together with that H+. And we write them on the same side of the equation so that they can come together, and that just basically shows that the base is snatching that H+. So, let's start there. H2PO4 minus plus H+. For a net ionic equation, anytime that you see that you have a charged ion, they're always going to be aqueous. So AQ, AQ. Also, we're dealing with acids and bases, so that's also aqueous as well. Now, I notice that H2PO4- is not on my list of 6 strong bases, so this is going to be in equilibrium. So I have to draw that double arrow. Now, I just have to figure out, well, what is my conjugate acid? All you have to do is just combine these two different, species together. But all you're doing is you're just gaining one H. So instead of H2PO4, I'm grabbing one more. So how many H's do I have now? Yeah, I got 3. So it'd be H3PO4. Now you just got to make sure that the charge is correct. And all the time that what you do is you take your initial base charge and add +1 to it, because you're adding that hydronium that has the +1. So we say, okay, it was a -1, -1, +1. -1 plus 1 is just 0. So I don't have to write a charge here, right? It's just 0. And since this is an acid, we write AQ. And we are done. This is the net ionic equation showing that H2PO4- can act as a Bronsted-Lowry base. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I will see you all in later lessons. I'll talk to you later, right? Okay. Have an awesome day. Bye-bye. I'm going to get some sleep. It's like, what is it? Oh my God, it's too late. It's 2:17. Okay. Bye.